and welcome to Lady Ada.
Hey, 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 welcome to a desk of Lady Ada. It's me, Lady Ada, here at my desk at home, wearing my comfy hoodie because it's cold outside, and with me is Mr. Lady Ada, the floating skull of death, and also on camera control.
Apparently.
Yes, and, well, we have some exciting sales going on this fine evening. Would you like to tell them about it?
Yeah, I would. It's Metro Monday. Check out the site. 25% off the Adafruit Metros, 15% off store-wide. Use the code, if you haven't already, AdaThanks at checkout. And on top of that, there's all the free stuff that could possibly go along with that. If you have an account, you get all the
Pins.
buttons, pins,
Feathers. Free shippings.
Yeah. I'll talk about Open Cyber Monday. It was a success.
Okay.
We'll talk about that later.
Yes.
But first, world premiere tonight. It is time. We've been talking about the SAMD processor for a bit, and you are going to show for the first time the Circuit Playground SAMD. This is a prototype.
Indeed.
Okay.
We got prototype PCBs today. They're white, so let's go to the overhead and I can show it off real fast. So this is the original Circuit Playground, which is black, and this is the SAMD Circuit Playground. I don't know if it's going to be white, but prototypes are white, and it features a different processor. Instead of the Atmega 32U4 USB processor, USB Atmel microcontroller, 8-bit, it's a Cortex M0 Plus 32-bit microcontroller with a ton of flash, a ton of RAM, built-in USB, and I also added a little 2 megabyte flash chip here, so it acts like a disk drive, so you can store your code and project files on here. So this is kind of designed for use with MicroPython or Arduino. You could use either. But in particular, MicroPython will run on this, which I think is really neat. To have a board like this that doesn't require a compiler ID at all. Other than that, it's very similar. You got that main chip. The reset button moved up here. I don't know if this is the permanent location. Here it's down over here, but that spot is now the SPI flash chip. Still have the 2 buttons. Still have 10 NeoPixels around, a slide switch. A little speaker, a little microphone, temperature sensor, light sensor, battery pack. I added a fuse here, and still has the 13 LED on LED over here. So pretty much the same peripherals, all the alligator clips with capacitive touch. But there's a couple things that the SAMD processor, despite being a little bit more expensive than the 32U4, has a lot of really neat things that it can do that actually let me reduce the number of components. For example, the 32U4 requires these 22 ohm resistors in series with the USB lines, and the SAMD doesn't, so I got to save 2 components there. The SAMD also has built-in a capacitive touch module for all of these outer pins. So if you select the outer pins to be on the capacitive touch module, you don't need, here I had 2 resistor packs with 1 mega ohm resistors. I didn't need those because it has self-capacitance capability, which is really nice. I put the speaker on a DAC pin, so that means I can probably get some nicer audio effects out of here. For now, I still have it connected to a basic Class A, transistor style amplifier, but I'm probably going to change that up to be a Class D, maybe, so I can get real audio effects. Even if that's a small speaker, but maybe still pretty good effects. Still have that same microphone over there. Still have the 3-axis accelerometer in the center. What else? Oh, because it's got the ability to do internal pull downs, I could drop the 2 pull down resistors for the buttons on the side. So a couple little things that I could do that just make it easy. Oh, another thing is you can kind of barely see. Maybe if we go to the, hey, what's up? We could go to the microscope. I brought my microscope out here. So over here, if people who watched the show over the weekend, I played around with porting bootloader and Arduino to the ATSAMD21E, which is a smaller version of this processor, just fewer pins. And I wanted to do it with a crystal-less design by using what's called USB correction for the crystal. So there's an internal oscillator inside of here, which is like, there's some tuning to it, but it's not perfect. It's not like good enough for USB. But so, I have a spot here that I could have had an external crystal, But with USB correction, it uses the 1 kilohertz starter frame pulse that comes out of USB, and it syncs automatically to that to make the internal oscillator, the 32 and 8 megahertz oscillator, a 32 kilohertz and 8 megahertz oscillator. It uses that to tune the PLL. And so having that as an input to the phase lock loop gets you like a perfect USB time clock. I think 48 megahertz time clock is what it uses. And so you actually, I didn't solder those components on. When I designed this board, I hadn't yet started messing around with that crystal-less flag for the phase lock loop. And so I left the pads here just in case, but I'll be removing these. So that'll be kind of nice to save 30 cents. Crystals are like pretty pricey, so being able to get rid of the crystal not only saves space, but also saves moolah, which means I might be able to add some other components on here. It helps cover for the cost of this 20-cent flash chip, but maybe, you know, if I have a little extra money or a little bit extra space, I might want to add some other components on here. I have some ideas for some extra sensors and peripherals that could be cool to add to Circuit Playground. So that's just the show, the close-up show. So then let's go to the overhead. Sorry, the overhead again. So the good news is that we got the 3 PCBs today and soldered them up, but there's some bad news, which is when I plug them in, this on LED doesn't light up. That's supposed to be green, and you know, when the light doesn't light up, you kind of put your hand around carefully to measure if anything is warm, and the regulator is warm, which means it's internally thermally limiting because something is shorted on the design. And one thing I always do is, it's a mixed bag, but I usually try to connect 2 boards and see if I get the same issue, which I did, which means it's either a design flaw or a PCB flaw, which does happen with prototypes once in a while, or the most likely cause is putting a component in upside down or backwards or rotated. Happens a lot. It happens a lot, more than you would probably like to think it does. Happens to me all the time. So the first thing I want to do is check against the, I don't have the, see, some of the markings that aren't visible because it's kind of tightly packed. So what I'm going to do is I'm going to check against the board layout on the computer. So let's go to the computer. And here you can see Angel and AdaBot hanging out. Metro Station. Pretty cool. Metro Monday.
Excuse me. That's our website.
That's our website. And this is the design.
Angel's the director of shipping.
Yes. She
AdaBot's the director of AdaBotting.
Yeah, and then here's some giveaways.
Yeah.
Yeah. Let's go back. Look at that. Isn't that cool? Aren't they having fun?
This is my happy place.
They're having a lot of fun.
Everything's okay.
Okay, so the first thing I want to check is, well, one thing you want to check really fast, because this happens a lot, is check the USB connector, because there's often bridging under the USB connector. I just noticed micro USB connectors, there's something about like the connectivity and the shield, it just makes them likely to have bridging. So check that out. So I checked that out, but there's nothing there. And then next up, you want to check the main chip. And this is that dot for pin 1. So we go to the microscope really fast. And kind of, oh man, you need actually a point. So these days, you know, they don't print on the chips, they laser etch. So you kind of have to like.
Want to get my flashlight?
I don't know. Yeah, we can try a flashlight. It's like, see how it's like really hard to tell. But there is a dot. It's right there. Yeah, there you go. If I tilt it, you can see the Atmel, and then you can see the dot. So that's good. Next up, let's look at the flash chip. The flash chip, the dot is actually closest to the microcontroller. So let me just check that. Yeah, there's that dot. Okay, so that's good. Also look for bridging while you're looking around. Although 2 boards, you know, if you have bridging on 2 boards, it's more likely a placement issue. Okay, next up, accelerometer. These also often have bridging underneath. So the dot should be up in this corner. Yeah, this is,
There you go. Oop, got it. Yeah, that's all good.
Oh man, you like totally cannot see the dot. Okay, this one I'm gonna have to use my eyes. Or maybe I can shine. I just wanna see if I can, no, there's like no way to see it. So, you'll just have to trust me. You look at it.
Want to try on the overhead? Because you can get in pretty close there too.
Yeah, we can try. It's just the dot is so small. But it does have better visual. So yeah, this is the dot right here. And that is the correct location. So that's good. And then the speaker only has 3 pins. Buttons look good. Check the NeoPixels. You can actually check them against this design. Make sure all the chips are, little chip dots are pointing in.
Mike is in chat, and Mike says that the circular LEDs on the microscopes are, yeah, we're going through the same thing. A flashlight
They're like
angle
the
helps.
worst.
And Mike is getting one of those little IKEA lamps that Ben Krasnov recommends. So we should,
yeah?
Yeah, we want to try that.
Oh, you know, we have a little USB.
Yeah, I'll find it later.
We have a little snaky lamp, so maybe we'll grab that later. It's okay for, a couple things. Anyways. But yeah, the light on this thing is actually kind of good. Maybe so you can see the dot here, barely see the dot there. But they used to print, and then down here, let's see where it is. There is a dot over here on this corner. So let's check. That is the correct location, which leaves only. And other than that, you can just check for components, like make sure, it's like, it doesn't happen very often, but once in a while, if you switch a resistor and a capacitor, especially if it's a low value resistor, that can cause shorts. And then the last component is this, is the microphone, little MEMS mic. And this is actually where I made a classic tragic mistake. So can you go to the computer? Okay, I didn't make a mark for pin 1 here. See, this is my fault. There should be either a pin 1 mark or there's a little hole where the MEMS mic. Actually, it's interesting if you look at the data sheet for this MEMS mic. Inside there's a little microphone, a diaphragm, and then a separate sensing chip, and it's wire bonded in. But if you look at the data sheet for this chip, which is the SPW, let's see if I can just see the data sheet link. There's no direct data sheet link. I'll go to the product page, and I think I linked data sheet. Nope. All right, let's go to DigiKey. They usually have the data sheet. Data sheet. And let's see the pinout. So pin 1 is closest to the hole. This is top view and this is bottom view. So this is over here. Okay, so let's check. And unfortunately, yeah, so I don't have I didn't put the marking on here. But pin 1, yeah, see, this is a problem. I should have marked it. So what I'm going to do is first I'm going to turn, TDocu is on. So this is actually my fault. I'm going to open up the library object. And find the object. Oh, I did have a marking, but what is this layer? DXF layer, see, it should be something like tplace. So let's put it on tplace. That'll be more useful. So save that, and then we could just update. Donk. Okay, so pin 1 should be on the right, but when we look at the PCB, can you go to the overhead? I put it on the left. So that will absolutely totally make it not work because it's connecting to, it means that the ground trace here is shorted to the 3 volt. This is a 3 volt top plane. So what I just did is I shorted 3 volt to ground. Bad, don't do that. And the reason I made the mistake is because on the previous design I had pin on the left and I sort of was like, oh, I'll just, you know, it's probably the same. I didn't remember that I flipped it upside down because I made a design change with this. I didn't end up needing to make a voltage reference, and so like ended up being easier to route. So I flipped the board flipped the chip and the sensor upside down. So what I have to do is I have to hot air this little fella off.
You flipped a chip.
I flipped a chip, and not on purpose though. So what I have to do is I have to hot air this off carefully because I don't want to take the. Well, I might just remove the whole thing and then just get everything else working. But hopefully if I remove this, then I won't have that short to ground, and then, you know, I can at least test the rest of this. So let's hot air it really fast over on the workbench. So I'm going to move this over here, get my vise.
All right, well, while you do that.
Yeah, over here. What?
Oh,
Hi.
I got that pretty fast.
Yeah, we're really fast now. And I have this really cool, did you want to show people the little, what's it called,
Yeah.
oh wait,
Let's,
you did grab the microphone.
Yeah.
That's what I was listening. Hold on. Oh man, it got totally caught. Under the Ethernet. Okay. Put that on the scope. Scopes are great for holding microphones. Okay, so yeah, I got this like cool little display. You can show stuff. Okay, so let me. Yeah. Sweet. Okay, so got my hot air. I'm going to try not to destroy the entire board like I did over the weekend. And yeah, the secret is I don't want to take the can off. I just want to take the whole thing off. So you have to be patient, caring. Don't mess it up. You can do it. Oh yeah. Okay, so then I'm going to flip it around. Whoa, there's fireworks. People really love this show.
Winter attack.
Okay. Is it fireworks or
I don't know.
terrorists? Okay. Okay, great. So while I'm here, I'm just going to quickly look at that accelerometer. The accelerometer looks good. This accelerometer, you know, when you reflow it, like in production, it's fine, but prototypes, it's kind of a bear. All right. So that's been fixed. All right, let's see if it turns on.
Going back.
Yeah, I'm done. So easy. So I didn't destroy the entire board. All right.
That's weird. Freaking knocked that off. There you go.
There you go. Surprising it recovers from HDMI failures. Okay, so this is my board now. So this is the hot one. Let's see if I can cool it off a little bit. Warm myself up and then plug this in. Come on. Oh, that wasn't it. Okay, so something else is amiss. Huh. I was kind of hoping that would be it. other, make sure that this USB cable's working. Yeah, that's working. Okay, so let's check out, let's go through the components again. Okay, chip, main chip, I don't see any significant bridging. Okay. Flash chip, pins in the right location. List 3D.
Is the LED on backwards?
No, the LED is on the right because that didn't change. That's a good thing to check, but I can also feel that the regulator is getting warm. Let's see, op amp looks good. Another thing is, you know, as I reworked this microphone, I could have like messed something else up. So you know what? I'm actually going to, I'm just going to remove the whole thing completely. So back to the hot air.
All right.
I'm going to do this till I get it right. And then, just because I'm being paranoid, I'm going to remove the accelerometer. This is like my dentist, always like, you know, let's just remove teeth. Why not? You know, could be a problem. Yeah, there could have been a bridge underneath here. These are annoying to hand solder. All right, so we can always solder that back on. There was a little bit of a bridge. Let's see. There may also be a little bit of bridging over here, but kind of tough to tell. Oh, maybe I'll hit it with my iron. Like right there. Teeny little bridge, but you only need a teeny little bridge. And then check for shorts. I once got a proto PCB that is short from power to ground on the in the copper by accident. There was a copper splotch. That was really annoying. I haven't had that happen to me in a while though. Got one tombstone. That's not gonna cause problems. Okay, so let's this is cooled off enough. I'm gonna try again. Okay. Let's put this in. Oh, yay! Okay, so that must have been it. So it was either the microphone or the accelerometer. So now that I know, I mean, here's the thing. I can bring up the rest of the board, and then I can always add those back because all I really need to do the main test is the microcontroller and the flash, and then I can test the NeoPixels, the buttons, the speaker, switch pattern, all that good stuff. And then once I know that all that stuff's working, I can go back and, you know, hot air reflow, whatever, that little microphone, and the accelerometer. But the fact that it's even powering on is great. So that's pretty good. I mean, like, that's par for the course. Usually, especially when you are hand putting together prototypes, getting bridges underneath chips is so common that what I used to do, it's more time consuming, and so it's a trade-off, is you can only solder in certain components at a time. With surface mount, if you have a reflow oven, it's a little easier to do all the paste, place all the parts, put it through the oven. You know, that way you can get more prototypes done, but there's that risk of you don't know what component failed, whereas if I started with just the micro USB and then the power supply and the microcontroller and then gotten that working and then added NeoPixels, there would be, it would be easier to determine what went wrong, but you also risk damaging parts because every time you touch the board, especially if you are dealing with LEDs, like these don't, if you have hot air, they melt very easily, the buttons melt very easily. The microphone, the cap comes off pretty easily. They're not meant for rugged handling. They don't like your little sticky hands. They're meant to be pick and placed and reflowed once at, a perfect reflow profile. But this is a good start. So the next step, what I got to do is I got the SWD pins on the back to save space. There's no SWD connector. I will solder wires to those and then use my trusty J-Link to get that bootloader I did over the weekend onto this chip. And then we can, slowly test each component, starting with the LED and then the NeoPixels and the speaker and the buttons and all that.
Okay, so we'll do that during the week.
Yeah.
Maybe tomorrow night.
Very exciting. Lots to look forward to.
Yeah. Okay, well, other stuff that was going on. Today was Cyber Monday.
Meow.
I have detailed files on catnip. So instead of it just being a buying spree, we decided to reach out to some sites, and a few of them posted up about this. Hackaday and Make and MakerIO DigiKey. We had this idea where it would be Open Cyber Monday, and Open Cyber Monday is where everyone just says, here's some of the open source hardware, software, or just generally good organizations like EFF and more, and just tweet about it and just help get the word out. So we have a blog post on our site. It has all the companies and people and things that people wanted to support. So things like from Apache to the Python Foundation to just all the stuff that we all use every single day. We've built this entire internet on open source, and worked out.
Yeah.
Yeah.
We're here. We're doing it.
I'd say there's probably a couple hundred tweets altogether.
That's
not bad.
cool.
Yeah, not bad.
Good.
And,
maybe you started a trend. Maybe every year there will be a Cyber Open Monday donation spree. I mean, look, if you don't have money, donate your time, donate effort, whatever you can. But there's a lot of people who basically built the base of the internet for free.
Yeah, we got archive.org in the list, Wikipedia, Creative Commons, WordPress. Just a whole bunch of open source efforts. And even if you're just like giving $10, you can just say, hey, thanks. And like, that's what a lot of open source contributors want to hear, just like, thank you.
Yeah. It means a lot.
Yeah. So we got that going on. That worked out. And then I guess the other thing is, I was watching the animated Dark Knight Returns, and now I figured out why I really want to kill AVR Man, because that's Superman.
Yeah.
Okay? And here comes Sam. So when we talk about
Is
the
Sam
Sam
Lady Robin?
Sam is just the next and better. Who's going to save you from AVR Man?
When he goes crazy.
Yeah.
Okay.
So Sam is a creation of ours. We're pitching this to Atmel, and we're hoping they adopt Sam as one of their mascots, because they got AVR Man in like every conference and everything. There's this AVR Man, and I think the times are changing.
Yeah.
So we'll see.
I like Sam.
Yeah. Anyways,
she's sleek and fast and has a lot of great peripherals. What?
Yeah. I mean, it's just like, it's kind of the jock to beat you up.
Yeah.
So anyways, so that's stuff that we got going on.
Okay. Well, I'm going to keep bringing up the SAMD board every day. We'll do a little bit. Maybe get the bootloader that I wrote over the weekend. Actually, the crystalless bootloader should just work. And then, basically just adapting the code, and then maybe Scott will get us a MicroPython image. We'll burn that in, and then we can start.
He's in the chat.
We can, when Scott stops, get out of the chat and give me that image. No, sometime this week, and then we'll be able to test. I like to test everything in Arduino first, because it's easy for me. Like I have the code ready to go, and then we'll go and we'll test it in MicroPython.
Yeah. And
then we'll get MicroPython core support for all of the accessories, like the speaker and the microphone, and have little helper wrappers. Like for example, reading the temperature. We'll probably have a little helper program that, like on the Arduino, it takes the analog reading and then converts it to a temperature reading by doing the math.
Yeah.
Boltzmann.
Yeah. Special shout out.
Shout out to Boltzmann.
Caleb from Make, who posted up today, helped
All
out
right.
with the Open Cyber Monday.
Nice.
All the folks at Hackaday.
Caleb.
Yeah.
It's not a C, but-
you know, it only takes a couple sites to get the word out and to start a movement. So that's as easy as it is. So let's
Caleb Craft.
let's think of some other ones too. Maybe this year, but also next year, that we can all work on together to get the word out about the change and the things that we want to see in the world. Because I think, like, yeah, we all bought shit from Amazon today. It just happens. But there's other stuff while the credit card is out we can do too. And you know, sometimes you gotta just do to show folks what's possible.
Yeah.
So we'll let everybody know if Atmel will adopt Sam. We've got some plans and ideas.
Yeah.
Maybe we can get everyone to do this.
Well,
'cause,
it's microchip. We have to get microchip too. Maybe she was red. If her outfit was red instead of blue.
we could talk to her agent.
Yeah.
All right, so that's it for tonight.
Okay. All right. Thanks, everybody.
Bye bye.
That's a good one. That is the red.
Maar ik vind helemaal pap.
Ja, dus
Dat